Hello people, in this video we take up some questions on conversion of number systems which have been asked recently in the GATE examination, that is maybe in the last 10 years. Let us look at the first question. We are given that the number system is of base r, the radix is r, and we are asked that for what values of r is this equation going to be true. Okay, so one thing that this question teaches us is, generally questions test thing, this question is going to teach us something, which is don't rush for the answer. We've already learned, you already know that root 121 is 11 in base 10 in decimal system, and see the intelligence of the people who are making the question paper. They've given option A itself as decimal 10. Don't rush for the answers, right? Don't rush to tick the answers. Maybe in hurry you tick answer A and end up getting negative marks. Just look at the procedure of solving this. Suppose 121, we've given that 121 is a number in base r. Just convert it into decimal. The procedure is you multiply with the weights of the bits. So you get r square plus 2r plus 1, which you can write as r plus 1 whole square. Okay, r square plus 1 plus 2r can be written as r plus 1 whole square. So under root 121 in base r can be written as under root r plus 1 whole square. Fine, so this root and square cancel and you get r plus 1 in base 10. Now just look at the RHS. The RHS is 11 in base r, which also can be written as r plus 1 in base 10. So you see the LHS of this equation and RHS of this equation are always going to be same for all the values of r. Whatever be the value of r, this LHS and RHS are going to be same. But one thing that we can note here is, what cannot be the value of r? Since you are using 1 and 2 as valid symbols in this number system, 2 cannot be the base of this number system. The base must be greater than 2. So what is the answer going to be? Any value greater than 2. B is going to be the correct option. Okay, look at the next question now, which was asked in 2014 for 1 mark. What are they asking is that what could be the valid base for which this equation would hold valid, for which this equation would be true. Okay, you all can see that this equation is not true for decimal number system, right? For decimal number system, the answer must have been 15.6, but you can clearly see the answer is 13.1. So we have to find the base of the number system. Okay, to solve this, what I am going to do is I am cross multiplying. Okay, in the same base, let the base be r. So I have multiplied these numbers. Okay, now I am converting all these numbers in decimal number system in base 10. So what can I write this number as? I can write it at 3r square plus r plus 2 is equal to 2r plus 0 into r plus 3 plus r to the power minus 1. Okay, we've already seen this, right? When a number is after the decimal point, after the binary point, you multiply it with the weight of r to the power minus 1. Fine, just multiply these terms, you get 2r square plus 6r plus 2. Since now you've converted these into decimal numbers, you can multiply them as normal mathematical calculations that you do. LHS remains the same. Rearrange these terms to make a single quadratic equation. You get r square minus 5r is equal to 0. So what values are you getting for x? You get r as 0 and 5. Since 0 cannot be a valid base of number system, so we discard this value and we get the answer as 5. You can check this answer also. Convert all these numbers into decimal using the base 5. So 312, if you take this number as a number in base 5, you get it as 3 into 25 plus 5 plus 2, which is 82. 20 in base 5 would be 10 plus 0, which is 10, and 13.1 would be 5 plus 3 plus 5 to the power minus 1, which is 8.2. And also 82 by 10 is going to be 8.2. So the answer is correct, which would be 5. Okay. Look at the next question, which was also asked in 2014 in some different set. This question says that 123 in a number system with base 5 is equal to x8 in base y, and it's asking for the number of possible solutions. Just convert both these numbers into decimal. 123 with base 5 in decimal would be 5 square plus 2 into 5 plus 3, which is 38. Convert the RHS also into decimal. You get xy plus 8. Okay, cool. So now what you're getting is xy plus 8 must be equal to 38, which gives xy should be 30. So we've got two variables, x and y. X and y are unknown, and it's asking for the number of possible solutions. Just look at what can be the possible values for x and y. If x is 1, y can be 30. If this is 2, this can be 15, 3 and 10, 5 and 6. Then you get 6 and 5, 10 and 3, 15 and 2, 30 and 1. So these are the number of possible solutions for x and y. But as we all know, all of these cannot be the answers. Why are these not? All of these are not the possible solutions. See, because if y is 30, x can be 1. So this is possible because the digits in the number cannot be bigger than the base of the number system, right? So if y is 15, x can be 2. So this is possible. What I mean to say is y must always be greater than x. Y cannot be less than x, right? We know this. The base of the number system must be greater than every possible symbol, every possible digit used in that number system. So for all valid representations, y must be greater than x. In all solutions, y must be greater than x. So we can only take the solutions in which y is greater than x, which is 1 and 30, 2 and 15, 3 and 10, and 5 and 6. Right? And all these solutions in which x is greater than y, these are not valid. You know the reason, right? So what are the number of possible solutions? We've got 4 possible solutions. So the answer is going to be 4. Look at one more question from GATE 2009. So what are they given? What have they given? They have given a number in octal number system, and they are asking for its equivalent in hexadecimal or maybe in decimal. You remember one thing we have learned, that if this is one number and I2 is another number in base R2, and if R2 is greater than R1, then I2 is going to be less than I1. We've also seen an example for this thing. If the base of a number increases, the magnitude of the number is going to decrease. Here see, the base of the given number system is 8, and if we are going to convert it into a number system with base 10 maybe, this number must have decreased. This should have become something less than 1217, but in the option they have given it as 2297, which is not possible. So C cannot be the answer. Similarly, 1217 cannot be the answer. So you have to check between these two options. And to convert a number from octal to hexadecimal, you know what to do. You first convert this number into a binary number. To convert it into binary, represent each bit with 3 binary equivalent bits. One can be represented as 001, 010, 001 and 111. So this is the binary representation. Now to convert it into hexadecimal, you start with the LSB and make groups of 4. 1111 is F. This is 8. This is 2. And this is going to be 0. Even if you append 3 zeros more, it's going to be 0. So the correct option would be B. Okay, look at the next question. You are given that this equation for 3 in base x and y3 in base 8 are equal and x and y are unknown. So they are asking for the number of possible solutions. Just convert both these numbers into base 10 into decimal. When you convert this 3 base x into 10, it's going to be 4x plus 3. When you convert y3 base 8, this is in base 10, into base 10, this is going to be 8y plus 3 in base 10. Now I'm going to equate them. So 4x plus 3 is going to be equal to 8y plus 3. So what we get from them is x must be equal to 2y. Okay, so now you know how many possible solutions are there, how many valid values of x and y are going to be there. There can be infinite number of values, right? If you take x is equal to 1, y is going to be 0.5, though 0.5 is not a valid base, but that's a different value. We're just talking about the values of x and y. If you take x as 2, y is going to be 1. So there are going to be infinite number of solutions. But what is going to put a restriction here is the possible values of y. The possible values of y are only from 0 to 7. Since 8 is the base of this number system, y can only take values from 0 to 7. Fine. So I'm just going to make a table. Y can be 0, which brings x to be 0. Y can be 1, which makes x to be 2. If y is 2, x is 4, 3, 6, 4, 8, 5, 10. I'm continuing it here. If y is 6, x is going to be 12. And y is 7, x is going to be 14. Y cannot take values more than 7 since the base is 8, and we all know that in a number system with base r, only digits possible are from 0 to r minus 1 in a conventional way, right? So now these are the 8 possible solutions, but also there is some restriction on x. X must be greater than 4. X cannot take values equal to or less than 4 for the same logic. So these 3 values are not valid. But x can take values 6, 8, 10, 12 or 14. And y can also take values 3, 4, 5, 6 and 7. So these are the 5 valid solutions. So the number of possible solutions would be 5. Okay, let's just look at the last question from this set. This was asked in 2017. In GATE examination for 1 mark. What are they saying is unsigned integer. Unsigned integer are the ones that we have learned till now. Okay, so the unsigned integer x in hexadecimal number system was BCA9. This is the representation in hexadecimal, and they are asking for the representation of the same number in octal number system. So you know the procedure, right? How we go. We convert this into binary first, and from there we convert it into octal. Okay, so B means 11. 11 has the binary representation as C is 12. 12 is can be represented as 10 can be represented as, and finally 9 you can write as. So this is going to be the binary representation of the given hexadecimal number. Now you have to convert it into octal number system. To convert into octal, we start making groups of 3 starting from the LSB. 001 is 1, 101 is 5, 010 is 2, 110 is 6, 011 is 3, and since we have one digit left, I am appending 2 zeros. This becomes 1. So the answer is going to be 136251. This is the representation in octal number system. So the answer is going to be option D.